My goodness, that took forever. All right, part 5. Here we go. Write an exponential function in the form y equals ab to the x whose graph passes through these points. Okay, so we need to know what a and b are. So we're going to solve for a and b. And how we're going to do it is they've given us 2 points. Remember, points are x comma y. So I can write one equation with 275. The y, I'm following the y equals ab to the x. So the y is 75 equals a times b to the x is 2. And then we're going to write one with 1875. Y is 1875 equals a times b to the 4th. So this is a system of equations. There's 2 equations. We can solve for a and b. So we're going to take this top one and solve it for a. So I would divide both sides by b squared, getting 75 over b squared. So I solve that for a, and now I'm going to place a into the other equation. So rewriting the blue one, this pen isn't working very well, 1875 is equal to a, which is 75 over b squared times b to the 4th. Now we can simplify. B squared, both the b's on the bottom cancel with 2 of them on the top, leaving 2 left over. So now we have 1875 is equal to 75b squared. Now I'm going to divide both sides by 75. 1875 divided by 25 is, 1875 divided by 75 is 25. So 25 is equal to b squared. So that would mean b is positive and negative 5. But we have, think of where these points are. Over 2 up 75, way up there. Over 4 up 1875, way up there. So this is a growth function. So our base for an exponential is not going to be negative. So we're going to disregard the negative one and just keep the positive one. So b is equal to 5. So now we know b is equal to 5. I'm going to come back over here and plug in the b as 5. So that'd be 75 over 5 squared, or 75 over 25, which is 3. So a is 3, b is 5. We can now write the equation. Y equals, I'm following a times b to the x. A is 3 times 5 to the x. And there we go. If $7,200 is invested at a rate of 5% compounded continuously, what amount of time, we're going to be solving for t, what amount of time would be needed to have a balance of 9,360? Use the formula. They give us the formula for compounding continuously. Round your answer to the nearest hundredth. Bubble your answer. We don't have a grid, but that on the multiple choice test, you would. So we're just going to find our answer. A is equal to P times E to the power of RT. So we're investing 7,200. That's the P, the principal. 5%, that's our rate. What amount of time, that's our unknown that we're going to be solving for. To have a balance of 9,360, that's the A. That's the amount you end up with. The amount you end up with after you invest a certain amount, P times E to the RT. So we're going to replace the A with 9,360 equals P 7,200 times E to the power of 0.05 T. So remember, E is just E. E is like 2 point something. It's a constant like pi. Okay, so we have an equation that we need to solve for T. T is an exponent. So this is where logarithms come in. Because there's an E in the problem, we want to use natural logs rather than log log base 10. We use natural log because it's log base E. Alright, so what we want to do is get the base and the exponent to be alone. So our first step here is going to divide both sides by 7,200. Cancels over there. 9,360 divided by 7,200 is 1.3 equals E to the 0.05 T. So now what we do from here is we take the natural log of both sides of our equation. Natural log of 1.3 equals the natural log of E to the 0.05 T. Now when we do this, if you remember your log properties, if you have natural log of E to the something, that this whole thing just equals the exponent. We had one of our properties was the natural log of E equals 1. And then if there's an exponent, I'll just call it A, it equals A. I guess the in-between step would be that you throw the A in front of the logarithm to be a multiplier. And natural log of E is 1. That's a funny one. 1. And A times 1 is A. So this whole section just equals 0.05 T. 0.05 T is equal to the natural log of 1.3. Now we can divide both sides by 0.05 to get the T alone. And T then is just the natural log of 0.3 divided by 0.05. So I would find that in my calculator. Natural log of 1.3 equals divided by 0.05. And that is 5.25 years. T for these financial problems is always, T is always in years. Number 37. State the domain and the range of our logarithmic function. So you can graph this and see what it looks like. So I put it in the graphing calculator, and it does the HK thing again, the opposite same. So there's no number on the outside there, so it's not being moved up or down. It is being moved to the right 5 units. So that means we have our horizontal asymptote through positive 5, x equals 5. Remember, logarithms, exponentials go, there's growth and exponential decay. They have horizontal asymptotes, where a logarithmic growth has a vertical asymptote, and it will look like this. So this guy is doing this. And I can do a real rough sketch like that because they're asking of us for the domain and the range, which is easy to ascertain because we know this asymptote there is at 5. So the graph is on the right-hand side of 5. So our domain, x such that x is greater than 5, not equal to, just greater than because it doesn't cross the asymptote. And then the range, it's going down forever and up forever. So y such that y is all real numbers. Number 38, condensing. So we've got logarithms. It's a natural log, but that doesn't matter. So remember, natural log just means log base e, so they have all the same properties. One by one, we're going to combine these. So if I have 2 logarithms being added, I can combine them into one logarithm through multiplication. But what I want to do first is any multipliers that are in front, we're going to kick those up to be exponents. So 4 natural log of a is natural log of a to the 4th plus natural log of b to the 3rd minus natural log of c to the 2nd plus natural log of e to the 6th. Now hopefully you remember from just a couple problems ago, we talked about that the natural log of e to whatever number equals whatever the exponent is. So that whole last term here, that just equals 6. Okay, now I'm going to start combining my logarithms. These are added, so I can combine them into one logarithm through multiplying. A to the 4th times b to the 3rd minus natural log of c squared plus 6. Now we can take these two and combine them into one logarithm through division since there's a subtraction. So one natural logarithm, and we would have a to the 4th, b to the 3rd divided by c squared plus 6. And that's it. We did it. We condensed this into one natural logarithm. One logarithm, and then just plus a constant. We can't combine a logarithm with a normal number. So we're done. Evaluate the expression log base 5 of 192. Now if your calculator does not do, I know some of your calculators do log base whatever you want, but most calculators only do log base 10. So we have to use the change of base formula. And so the change of base formula says this, that log base 5 of 192 will equal log base 10 of 192 divided by log base 10 of 5. And so then we can just punch that in our calculators. And that is 3.266666. It says to round to the nearest hundredth. So our 6 makes the previous 6 a 7, giving us 3.27. Number 40. Solving for x when x is an exponent. Now, what I would first look to do is, can I change 347 to be 9 to some power? Because if they have the same, say it was some number, if they have the same base, you can set your exponents equal to each other. Working with my calculator a little bit, it turns out it doesn't work There's not a whole number. 347 is not 9 to a whole number power. So this is where we would use logarithms. So I can either take the log of both sides, or I can convert this exponential expression into a logarithmic expression. I like taking the log of both sides. Log of 9 to the x equals the log of 347. And with our properties of logarithms, exponents can be thrown down in front to be a multiplier. X times log of 9 equals log of 347. And then we would divide both sides by the log of 9. So now our x's alone. X is equal to log of 347 over the log of 9. Now, this would be an appropriate way to answer it. But if you're multiple, this is the exact answer. And then we can approximate it by putting it into our calculator. So it'll just depend on what the multiple choice answers are like. If they're decimals, then pop it in your calculator and get a decimal. If they're written with logs, then that would be good enough. And number 41. Solving again, the variable is in the exponent, and I'm looking at the bases, and I'm noticing I can write 16 with a base of 2, because 2 to the 4th is 16. 2 times 2 times 2 times 2. So I'm going to rewrite that. 2 to the 6x is equal to 2 to the 4th to the x plus 8. And so now what we're going to need to do is simplify that. When I take a power to another power, we multiply those powers. 2 to the 6x is equal to 2 to the 4x plus 32. Now that we've got our base is the same, base to a power, 2 to a power equals 2 to a power, we can now set our exponents equal to each other. Therefore, 6x would equal 4x plus 32. Subtract 4x both sides gives us 2x equals 32. Divide both sides by 2, x is 16. And number 42, and I think, yep, that's it. That'll be the last one. All right, we're solving an equation, and there's logarithms in it. Now, one of the most basic properties about solving with logs is, remember, you can cancel. It's not really canceling. It's using the property, but if I have just a single log of whatever equals log of whatever, I can set the whatevers equal to each other. So whatever's in here equals whatever's in there. It's like you're canceling the log on each side. But I can only do that when there's one log equals one log. This side does not have that. There's two logs being added together. So what we can do is use our condensing rules to condense those into one logarithm. So our left side, log base 7 of 3x plus 14 is equal to log base 7. It's a plus, so I would multiply their parts. So it'd be x times x plus 8. Now we can set the parts equal to each other. So we have 3x plus 14 is equal to, I'm going to go ahead and multiply that out, x squared plus 8x. So we're quadratic here. We got an x squared and x, so I want to get everything on one side. I want my x squared to be positive. It makes it easier to factor or solve if it doesn't factor. So we've got x squared on the right. I'm going to minus 3x both sides. That gives us a plus 5x on the right. And then minus, oopsies, minus the 14. So on my, I'm looking at my answers that I uploaded. So I have another mistake. I had written plus 14 right here, which was the mistake because obviously we would subtract 14 both sides. And so then it didn't factor. So then I used the quadratic formula. So you're going to see that on the document that's on Teams. I will fix it in the morning and repost it, but FYI. So this one is factorable because 7 times negative 2 is negative 14. 7 plus negative 2 is 5. So that actually makes this easier. And I'm going to write my equals 0 on the right hand side instead of the left. So we're going to have x plus 7 times x minus 2. Therefore, x plus 7 is equal to 0, and x minus 2 is equal to 0, giving us x is equal to negative 7 and positive 2. Now remember, you can't have the log of a negative number. So I'm going to quickly go, you would always go back to the original and try both of your numbers to see if any of them give you a negative log, a log of a negative number. So if I plug in negative 7, that would be negative 21 plus 14, which is a negative number. So the negative 7 is not going to work. And then you can see if I plug in 2's, I don't get any. We would just have 6 plus 14, a 2 there, and a log of 10 there. So the 2 is fine, but our negative 7 is not going to work. So you kind of have to remember that because this is a multiple choice. For sure, one of the answers is going to say x equals negative 7 and 2. And then another choice is just going to say x equals 2. So you got to remember that you got to plug it back in to check. Alrighty, that is it.